At one point, a siren was heard coming from an ambulance that was speeding down the street. 3 people were able to record the sound of the ambulance at the same time. One person heard a low-pitched sound, one heard a medium-pitched sound, and one heard a high-pitched sound. They all heard the same sound at the same time, but it sounded different to each of them. Why was this so? Well, this happens because sound is a wave. A wave is a disturbance that propagates or moves from the place it was created. Sound is a type of a mechanical wave that exhibits characteristics common to all waves, such as amplitude, wavelength, cycle, period, and frequency. Amplitude refers to the displacement between the resting position and the crest or trough of a wave. A cycle refers to a full wave, which is from one point of a wave to the next point with a similar position and direction. Wavelength refers to the distance of one cycle. Period refers to the time taken to complete one cycle. And lastly, frequency refers to the number of cycles completed in a specific time frame.
When a wave source is in motion, the waves it emits gets tighter in the front or along the direction of motion and more spread out in the back. This also means that frequency is higher in the front compared to the back. A high-pitched sound corresponds to a high-frequency sound wave, and a low-pitched sound corresponds to a low-frequency sound wave. The reason why we get 3 different pitches is because of the relative motion between the ambulance, which is the wave source, and the observers. Because of this, a person in front of the ambulance will hear a high-pitched sound, a person at the back of the ambulance will hear a low-pitched sound, and the person inside of the ambulance will hear a medium-pitched sound, because the person is moving at the same velocity as the ambulance, and the person will perceive the sound coming from the moving ambulance as if they are both stationary.
To further understand this phenomenon, we will be showing a demonstration. To make the contraption, follow these steps. First, gather the following materials. Second, place the objects in the container. Make sure to use adhesives such as tape. Third, connect the buzzer to the battery. Finally, make a hole to insert the string and secure it. Now that you have finished making the device, you can now begin the experiment. Start this by running the Firefox app on your mobile phone. Then, select the Doppler effect under the sound options and enter the base frequency you chose to use from your audio source. In our case, the frequency is 1000 Hz. Then, position yourself in front of the phone with the Doppler effect experiment in the Firefox app running. Take the person in the video as an example. Then, you can begin the experiment. All you have to do is move towards and away from the gadget. The distance is around 2 meters. We can see from the data that the sound frequency is fluctuating. When the frequency increases, this means that the wavelength decreases, and this implies that the audio source is moving closer to the phone. Also, when the frequency decreases, the wavelength increases, which means that the audio source is moving away from the phone.
This phenomenon is called the Doppler effect, and it is also evident in other waves such as light.
Visualize a light bulb traveling at a relativistic speed. Similar to what happens to sound waves, the waves in front will be bunched up and the waves in the back will be loose. The observer in front will see a bluish-violet color, a characteristic of visible light with a high frequency and shorter wavelength. And the observer behind will see a reddish color, a characteristic of visible light with a low frequency and longer wavelength. Each of the other observers may see a different color depending on the relative motion with the light bulb.
In conclusion, the Doppler effect happens because of the differences of the relative motion of various observers with respect to a wave source.
Thank you very much for watching, and goodbye.